It's my honor and pleasure to introduce today's speaker, Mr. John McCool. Mr. McCool is Senior Vice President and General Manager of the Data Center, Switching, and Services Group at Cisco Systems. Mr. McCool received his bachelor's degree in electrical engineering from Drexel University in Pennsylvania in 1982, and his master's degree in computer engineering from Santa Clara University. Mr. McCool has over 28-year experience in networking industry, especially early days Ethernet. He has helped create networking standards and held several patents. Prior to Cisco, he worked at Synoptics, Advanced Microsystems, and Granite Technologies. He joined Cisco in 1996, 14 years ago, when Granite Technologies was acquired by Cisco. He grew Cisco Granite Catalyst series to multi-billion-dollar business. 2 years ago, he was promoted to his current position as the Senior VP of the Data Center, Switching, and Services Group. His group accounts for about $15 billion revenue for Cisco, out of Cisco's annual revenue of $40 billion. So essentially, his group accounts for 40% of Cisco's $40 billion revenue. Big responsibility. Going forward, he has another important responsibility of expanding Cisco's expanded presence into cloud computing and virtualization. Now please join me in welcoming Mr. John McCool, Senior Vice President of Cisco Systems.
Okay. Thank you very much. And thanks, Dean. Thanks for having Cisco here today. And it's an honor to be here. What I wanted to share with you today is some thoughts that we have at Cisco around how consumerization of IT is affecting enterprises. You know, when I started in the industry, enterprises really drove the nature of networks and computing. But today, you all have laptops, cell phones, texting, tweeting, Google, iChat. These are really the drivers of the next wave of IT, and it's impacting enterprises in a large way, and we'll talk through that today. We did ask a question here regarding use of polling, and we're going to be interactive during the session. I'm going to ask you a few questions. You can text or tweet, and we'll take a look at the results. So it seems like most of you are enjoying texting here today. So we'll talk about this changing world in a high-level way and how it's impacting consumers and your use of technology. We'll share with you our thoughts on how enterprises are attempting to react to these changes, and for the smart companies, how they're going to take advantage of these changes and drive the nature of their business. And then I'll have some closing remarks about how this will impact you. So how's the world changing? You know, we live in a world today where computers are acting more like phones. Phones are acting more like computers. We're all connected. We're connected globally. That certainly didn't exist a decade ago. And I think you're all evidence of how this phenomenon is happening right here in the room today. The use of video is just proliferating, especially in our personal lives. First question is, how much time do you spend looking at video or dealing with video on the internet? Now, when we talk to enterprises, they're also interested in video too. They're interested in using video to connect to CIOs. They may have a merger and acquisition. They want to deal face-to-face with a business person across the planet. They want to do e-learning and push out learning and curricula. They might have health care that they want to provide on a remote basis through video. So let's see, maybe we can take a look at the results. 1 to 5 hours, 33%. Now we have a lot of people looking, oh here, we changed here. There we go. 14% of the folks, over 10 hours of video on the internet. Video is very interesting if you're in the networking business because it has characteristics of huge bandwidth consumption, but it also has to be real time and interactive. And I saw outside today you have some digital signage. Eventually, video has to be completely connected through an enterprise. All these systems today are disparate. You may have a video system, a surveillance system, a telepresence system, a conferencing system, all on different networks. All this will be converging over the next few years. Now, as I was preparing for today and talking about these trends and thinking about where I was when I was sitting in a room like this, longer than I care to remember, I took a look at and asked Joe to pull up some trends that were happening, some things that were firsts during the decade that preceded me coming to the university. And if you look at some of these things, I would submit, with the exception of disco, all of these trends were long-term and had a great deal of impact and meaning on the industry. And I was very fortunate to get involved in fiber optics very early in my academic life, but never appreciated how that would come together with personal computers and the concept of wide-scale networking. And I was very fortunate to be able to, ride my career through those trends. And if there's just one thing I would say to take away, not just from today's lecture, but this entire series, you're going to see a lot of people talk about different technologies. And I would submit it's the people and industries that drive the confluence of different technologies that yield very true and lasting innovations in our industry. Thinking about the world that you've experienced in the decade before you came to the university, we've seen the rise of devices connected to the network. A decade ago, a personal computer would be the only device connected to an enterprise network. Now we're dealing with wide-scale mobility. Information, content available anywhere on the face of the planet, from large data centers, large content stores, and the concept of being able to be connected at any time. All of this happened in the decade before you came to the university. All of this is new. Now, when we talk to enterprises, we ask them how are they going to deal with this new world. They have to think about how they connect to their customers, their employees, and their partners anytime, any place, anywhere. Now, that's not how enterprises work today. How many of you have worked at a company maybe here in the Valley? Just a quick show of hands. Just a few, maybe 20%. It's not like this, right? You come in, there's a computer, it's usually a black computer, you log into your system, you're usually tethered. Many companies don't have guest access or even wireless access, and that's because they want to keep their information secure. But that's not going to work in the next decade, especially as you enter the workforce, because you're going to be expecting any information anywhere in the company to be connected to people both inside and outside the companies to do work. That has dramatic impact on the levels of security that have to happen in enterprises and how they serve information. Just a few facts here in terms of the amount of information that's being served on the internet over the last decade and the changes that brought with it. Just fantastic numbers if you look what's transpired in the last decade. And from a networking perspective, that's fantastic. What's also happening is just an explosion in terms of the number of devices connected to the network. Just 3 years ago, one device for every 5 people. Now multiple devices per each person connected to the internet. And by 2013, we're expecting 140 devices for each person on the planet that's somehow connected to the internet. Just staggering numbers. And when you add this up, the confluence of all this information and all these connections, you start to look at a world where there's going to be 1 trillion devices connected, over 1 million different applications, and zettabytes of information. So for you, thinking about entering your careers, I mean, how is that going to be stored? How's that going to be served? What kind of networks do we have to create to make that information useful and available to people? And today's enterprises are struggling with this today. They're wondering how they take advantage of the capability of video technologies, how they can enable their enterprises to communicate and work with a global workforce in a real-time nature, and then how they serve up their applications to both their in-house employees, but also their customers, and have their partners interact with the corporation while protecting their assets and their security levels. In the data center specifically, the rising expectations of being connected, we talked about that. Globalization, even the smallest companies in the Valley now have some kind of arrangement with another company in Asia or India or Germany. We see companies with 500 to 1,000 people all having disparate and interconnected enterprises. So this is driving them to look at the use of communications and collaboration software so they can deal with the real-time effect. Financial pressures, who's going to pay for these networks and what's that going to do to the bottom line, and how do I store all that information and the increased explosion of storage and deal with that in a cost-effective basis. And then how can I provision new services? If you're in the business of supplying some type of manufactured good or service, you're worried about your top line, and how can you provide new services to your customers in a that usually incorporates some kind of IT project to deal with a new business model. So companies are looking at their assets. They're looking across where their computational devices are stored, where their data centers are located, and they're starting to consolidate. Many of the customers we talk to may have up to 20 data centers scattered across the states or maybe across the globe. They look at consolidating them in 2, 3, maybe 4 data centers where they can get greater efficiencies. They start to look at taking the infrastructure and making it agnostic to the applications, and I'll talk more about that. Today's data centers are very rigid. Certain applications run on certain computers with certain storage devices. That makes it very inflexible. And then finally, how can they offload some of their work? Do I really have to run everything in my data center? Could this application be hosted by another provider? So we talk about on-premise applications and off-premise. And how can I deal with both types of services and actually reduce my cost? So we see 4 major areas where companies are really starting to invest. First, in the consolidation of their data centers, then taking advantage of virtualization. How many people were here last week for Steve Harrod's discussion about virtualization? Good show, right? So we'll talk about virtualization in terms of servers, but also in the broader context of a data center as well. How do these networks become application aware? It turns out if the networks are aware of the application and can increase their performance, you can actually consolidate more of your applications and data in centralized stores. And then cloud computing. What's that have to do with virtualization, and is this a reality for many enterprises? It's definitely a reality in our personal lives, but not so much today for the modern enterprise. Data centers are a big business. About 1/3 of the networking equipment we sell, we estimate goes into a data center. It's where all the IT assets are housed, where most of the servers are located. And this is what they look like. Can you imagine if your first job was to replace something in this data center over here? Pretty difficult, right? So we're developing technologies that will allow these data centers to become more aggregated. We call it unified. So the infrastructure can be much consolidated. You can reduce the number of computers. You can reduce the size of your network. You can reduce the size of the entire scale of the network. There's many opportunities for physical innovation. And what I mean by that is dramatically changing the way a data center is cooled and designed, being smart about the airflow. It turns out that 40% of the power in a data center today is consumed by the cooling effect and the air conditioning within that data center. So there's a tremendous opportunity for optimization around just the physical constraints of the data center. How many people here are in mechanical engineering? Good show of hands. So I think there's, I'm seeing a renaissance, I think, of cooling, thermal considerations, power management, and huge efficiencies. A power supply in a legacy data center may only run at 80% efficiency. What if we could design power supply systems that ran at 90, 95% efficiency over a consistent load? Dramatic impact in terms of the planet. But there's also underlying changes in terms of the compute style. And we think about the trends or waves of computing that have happened over the last 3 or 4 decades. And in some ways, it's a return back to the past. We've moved through this design styles where mainframes were highly centralized to a more decentralized compute model over the last few decades, and then returning to these large data centers connecting thousands of processors with 5 to 6 cores per each processor. And an old technology that was used in the mainframe days is coming back into favor, virtualization. And Steve shared with you, I think, ideas around server virtualization. It turns out this is extremely important as enterprises try to harness the power of modernizing. And I'll talk about why. So what is virtualization? It's this concept of abstracting applications or people from the underlying resources so you can become more efficient. And there's different examples of virtualization. There's some where multiple resources become one logical resource. Or you could have the opposite. You could have many resources, a single resource looking like it's many virtual device contexts. And it can be applied not just to servers and how you deal with virtual machines, so you can run multiple virtual machines over a single CPU. It can also deal with storage. So imagine if you have a large storage pool which is designed to be very efficient, and you can partition it into logical storage so you can become more efficient in terms of the overall capacity usage. It applies to a network. You may have one large network, physical network, but for some reason, perhaps for security reasons, you want to run it as separate logical networks, so break it down into segments. You'll often see companies have a separate development network and development capacity for new applications and a production network. So very commonly, they'll bring these two together in one physical network and use virtualization to separate them into 2, 3, or 4. And then virtualization of the client. So virtualizing a desktop on your phone or on your compute or on your home TV. So these are 4 ways that virtualization is coming into play today in the enterprise. Now, why is it so relevant? Well, the first wave of virtualization was just to get more efficiency out of computers. It was estimated 3 to 5 years ago that people were only using about 40%, 30% of the capacity of a modern CPU. So today with virtualization, when we talk to customers, they're running up to 90% capacity as they start to expand the use of virtualization. It's taking full advantage of multiprocessors and multiple cores. But it has another benefit. In the past, if someone was deploying an application in a data center, that application would be qualified to run on a specific computer, a Unix workstation, a specific version of Unix, a specific version of a Spark chip, a specific host bus adapter. That would be provisioned with its own pool of storage. So the application would see its own compute, its own store. If you decided to run a new application, you had to requalify that on a new compute stack. So this led to the sprawl and that complexity of cables because applications were rigidly bound to certain computers and certain storage devices. With virtualization, the application is logically bound to storage and to compute. That means the physical infrastructure, all the servers, all the storage, can be available for any application running on any core of any microprocessor anywhere in the data center. So just a fantastic improvement in terms of the efficiency of operations. What's more, if you want to run a new application, you can quickly fire up a new virtual machine, virtual storage, virtual compute, and put that application onto the data center. Or if it's a holiday time for a retailer, they may provision more virtual machines and storage for certain applications that they know are going to be in demand during that season, or tax time for people who are doing accounting. You can think about all the ability and effect that you can have in seasonal type of demand as people start to have more elastic computing environments. Now, we tend to think about the infrastructure at Cisco that goes into these data centers. And really, there's kind of 3 bubbles here. The compute platform, the multi-core processors, driving up to more cores and higher speed capability, the associated memory and I/O. The networking platform moving from gigabit to 10 gigabit to 40 gigabit. And the rise of these new virtualization software technologies that run on the compute element. And to make this systems more efficient, what we're trying to do is to innovate at the seams. We talk about taking the compute platform, increasing its memory size and scale, so it can run more virtual machines. So you actually increase the size of the computer to be more efficient, to making the compute element more aware of virtual machines as the atomic unit of computing. Those connections, all those wires that you saw connecting out of that data center, can we make that more efficient by converging the storage network together with an IP network and reducing the number of cables? We worked with the IEEE and developed a standard called Fiber Channel over Ethernet, so you can converge fiber channel SANs with IP. In networks and designs of data centers that use heavy block-based storage, we estimate that we can save about 8% of the power on those data centers. Now that might not sound like a lot, but when you consider that a modern data center only consumes, the network component only consumes 15% of the power, that's fantastic savings. We saved 4,800 cables in our own data center at Richardson, Texas by using that technology. And then how do you make the network aware of virtual machines? These things actually can move. Virtual machines can move from data center to data center. The network has to be aware of it. So the technologies that we're developing deal with the integration of these three bubbles. And we think about them in terms of the networking component we call the unified fabric, the compute element, the unification of the computing element so it can run virtual machines, and then services that run on top of the network, and I'll talk more about that. In unified fabric, we've developed a number of technologies that we think are critical to making these data centers more efficient. Being able to virtualize the switch, being able to run all the links active in the data center to increase the bandwidth, consolidate the I/O. And these technologies play at every level of the network. So virtual machines, as you start to expand their use, people talk about the proliferation of virtual machines. They're explosive. It went from 4 to 5 virtual machines per physical server. People are talking about 10 to 20. In a rack of 40 servers, you may have up to 500 virtual machines. The network has to be aware of those virtual machines so you can apply security policy. So we developed some technology called VN-Link that allows policy to be applied at the network level at the virtual machine. The concept of consolidating storage and IP with fiber channel over Ethernet. And then being able to run storage information over a multi-hop network using Ethernet as a lossless fabric with data center bridging developed by the IEEE. Then moving virtual machines from data center to data center, we developed a technology called Overlay Transport Virtualization, or OTV, that allows 2 data centers to run in tandem, and you'll be able to see all virtual machines across those data centers. Being able to take a firewall and separate it into logical zones and virtualize that firewall, or virtualize the switch with virtual device context. Being able to build large-scale networks with multiple switches so that all the links are active using a technology called Fabric Path, and so on and so forth. So I think the point of this is the network has to become aware of the virtualization in the data center, and technologies have to be developed and deployed to make it more efficient. In compute, the compute infrastructure has to become more programmatic. So if you're going to deploy new services more quickly, you have to have programmatic ways of developing what we call service profiles. So a new service can be automated and programmed into the compute element so new applications can be deployed. And then this concept of unification of network services. It turns out in a modern data center, firewalls are extremely important to provide security capability. Also, application-aware technologies like load balancing and application optimization through the network. So those services needed to be deployed in the data center, perhaps even on your laptop or out at branch offices. One way this is used is to actually bring applications that may have sit in a branch office or a remote office back into these very optimized data centers. Imagine an insurance company that may have multiple branches out in your neighborhood. A company like that with a branch may have 4 to 5 servers out at that branch because the insurance broker wants to access information and have it respond very quickly. Using application-aware technology, those servers can be brought back into the data center as a virtual machine, and the insurance broker can still have access to those applications because the speed through the network is accelerated through wide area optimization, using technologies like compression and indexing, able to cache effectively much of the information either at the branch or compress it as it goes through the network. We have a product at Cisco called the WASP that performs such a task, and it can be integrated at different points of the network. So it can be integrated into a router. It can be run in the data center as a virtual machine. And it can be run as some technology that's actually embedded in the networking device in the router by itself. And this becomes very interesting as enterprises try to deal with this consumerization of IT. You know, they really don't want to have to give you a laptop anymore. It'd be really nice when you came into a company, you started working there, you probably all have laptops or mobile devices, that they could provision you as an employee with all the applications you need to do your job. Today they do that by giving you a physical machine so they can assure the security level of that machine and hope that that machine doesn't get infected or come back onto the network and mess something up. What they're looking to do is actually deploy a virtual desktop. So all the applications that they would provision would appear on your cell phone, your laptop, or whatever device that you choose or you need for your particular role in the company, and to provision that laptop with virtual applications. So taking the same virtualization technology, being able to run an application or an OS on top of another operating system, and have all those applications provisioned back in the data center. Turns out companies spend a lot of money provisioning applications on desktops as well. They have to deal with all those devices, all the upgrades. This also lets them consolidate their resources in the data center and use those unified computing provisioning techniques to roll them out more quickly. So another quick question. What is cloud computing? A lot of hype around cloud computing. So everything I talked about so far are just general techniques that people are using to make data centers more effective. We'll talk about this concept of cloud and how enterprises view cloud. And I think many of you use clouds today in your daily life. If you're accessing Google, you're accessing a cloud. Why don't we take a look at the results? We'll make something up. I'll have to give you the answer if What is cloud computing? An iPhone in airplane mode. I don't know, Dean. I heard there was a good sense of humor here at the university. Okay, well, the 5% of you that answered number 4 got it right. So virtually available IT resources. You guys are just playing with me now, I think. So the official definition here is IT resources that are abstracted so you can deliver them on demand and at scale. On demand and at scale. Well, it turns out there's lots of different models for what people talk about in terms of cloud computing. And the National Institute of Standards actually went about creating a framework for how we talk about cloud and what that means. So they think about how the cloud is deployed, the deployment model. So a public cloud would refer to a large set of resources that were available to the public. So think Google or Bing, right? Some search engine. Private would be what we see a lot of enterprises doing today. They're taking their data centers and they're effectively turning them into a cloud to service their customers. The federal government's very interested in this. They have lots of agencies, people doing IRS, people doing government research, etc. What if they could build one data center with all the applications and serve them to multiple branches of the government? There's a notion of a community cloud. You might imagine a number of regional banks getting together and trying to save resources by building their own cloud that would serve different companies. That would be a community cloud. And then there's examples in between, hybrid clouds, so taking a public and private cloud and figuring out how to interconnect them. Now there's different service models, and what this means is if you think about software as a service, Cisco has a technology we call WebEx that we offer, which is basically a conferencing service. Or Salesforce.com is another example of software that's delivered as a service. Salesforce.com also has the ability to program on that environment, so you can use it as a programming platform. That would be a platform as a service. And then infrastructure is very interesting. Amazon EC2 would be an example of this. So you basically get a virtual machine, a virtual storage capability, and a virtual compute capability. That's infrastructure as a service. Now, if you think about what I said about the virtual machines becoming the new atomic unit of computing, imagine an enterprise that's running a number of applications in a virtual machine. They may decide, if they had the capability, to move that virtual machine out to a service provider or a hosting model that uses infrastructure as a service. So they don't have to run it in their physical data center any longer. That could be quite convenient if there's applications that aren't extremely important to the business that they view as being contextual. And then the characteristics, being able to be a measured service with broad access, being able to be accessed on any internet device, being accessed through the web, being able to be very elastic in terms of moving from different tenants or different applications on the fly, usually being provisioned by the customer themselves, as opposed to calling a 1-800 number and waiting for weeks before that service is turned up. And our view on this is, while this is happening in the consumer world in a very big way, it really has yet to make a huge impact in the enterprise. And the concerns largely are around security and storage of information. So we definitely are moving from a phase where enterprises constructed their own standalone data centers. Oftentimes, one would be a main data center and a redundant backup data center. They're now starting to run them both active, using virtual machine technology to load balance between. But they're quickly looking at creating their own internal clouds. So you can imagine Cisco having our own internal cloud for our own applications with provisioning capability on top of it, but augmenting their own resources with public cloud and public cloud type of services. So a lot of our customers today have in-house phone systems that we provide, but they're also augmenting that capability with WebEx for external conferencing. That would be an example of this hybrid type of an approach. And then these things moving more to a private cloud model and being more connected to the public cloud. So being able to move virtual machines or resources off and on premise in a more automated manner. And then eventually, we envision a world where people could construct mashups of different information or applications that are coming from a variety of cloud sources on their screen, on their plasma TV, or what have you. To do that, a great deal of work needs to be done. There has to be concepts of how you would federate these clouds. There needs to be the creation of open standards. And probably most significantly, how do you secure information? It turns out many industries and many enterprises are highly regulated. If you think about healthcare, it's regulated by a HIPAA standard here in the United States that makes sure that patients' records are maintained in terms of their confidentiality. I think many of us remember signing the form when we go to the doctor. So they worry a lot about where that information resides. They have to know exactly where it is. So the cloud actually creates a huge challenge. Is that information stored in the United States? Has it moved offshore? Banks are regulated. They need to understand where their information is and provide compliance. So security and compliance, enormous concerns for enterprises, and much different than the environment we have in our personal lives. So when we talk to enterprises, I can tell you that there is interest. Give you a clue. What percentage of those enterprises do you think are looking at cloud computing models? So greater than 70%. So this is an aggressive crowd here at San Jose State University. Big believers in the cloud. Turns out 50 to 60, so you're pretty close. You're in the zone. So this is the people now that are investigating cloud computing. I would say the reality of the usage of cloud computing in enterprises that you would think about in the Valley is actually much lower. And everyone is interested because of the ability to offload applications and storage and being able to pool them and be more efficient. But they're really worried about security and trust concerns. So people differ widely in how long they think it is before they'll use this technology from an enterprise perspective on a wide basis. And the reason for that is if they think about the data centers they have today, they think about them, they're trusted, that they can control them. They usually have employees or people that are outsourcing and running these data centers. They can go see them. They physically can point to the machines. They know they're reliable, they're secure, they can be audited. But they're very attracted to the flexibility of this model and the fact that it's dynamic and on demand and they can change very quickly. And it's highly efficient because you're virtualizing over a large number of machines, but also over multiple companies and multiple enterprises. So we believe the magic here is to combine these two worlds and have an effective use of virtualization and use the network which will connect the clouds together as a control point for enforcing policy and security and application visibility so people know what's coming from the cloud, what's being stored locally, and combine these two attributes together. So just let me leave you with a few final thoughts here. I think if we're going to get to this world of the cloud in the enterprise, and certainly we're enjoying that today, there's much work to be done, and I think much work that the people in this room could do. I think that there's tremendous opportunities in this transition, and I would submit we're only at the beginning of this. We haven't seen anything yet. If you think about moving to 10 connected devices or 20 connected devices or 140 per person, and the amount of information that has to be stored and shared over the network, and these huge challenges in terms of securing that information, and power and cooling densities that are going to be needed, I think you all have tremendous opportunities to really innovate, especially coming here as part of Silicon Valley with the companies that we have right here in front of us. So with that, I'm happy to take some questions. I think we can tweet our questions, or we can use the microphone.
Is Cisco going to provide some cloud computing like Amazon EC2 or that kind of stuff to the consumers?
So the question is Cisco going to create its own cloud computing like EC2? Our view is that we're going to enable companies to either create private clouds using our technology or service providers to create public clouds. We will run our software as a service, and that's with our WebEx conferencing platform. But we won't be hosting clouds or hosting infrastructure ourselves. And we're very interested in enabling enterprises to be able to use clouds and use the network to make sure that everything is secure and policies can be enforced. Great question.
On your last slide, you said there's going to be career opportunities, and I was just wondering what kind of careers is going to be.
I think there's, if I look at the technologies involved here, I think, obviously semiconductor opportunities in terms of creating next generation multi-core processors, increasing density of memory. Talked a little bit about the beginning of the challenges of cooling, thermal design, packaging. These are areas that we're pushing within our own products, and we see our customers also thinking about innovative cooling and powering techniques as they design their data centers. So opportunities around physical design, probably civil engineering. Security is a huge concern. So information technology and security. Next generation networks, high bandwidth fiber optics. I mean, there's so many different types of technologies that are involved here in the data center. Virtualization, provisioning. So provisioning, management and provisioning types of software has to be created. It's not very automated today, so people are interested in how they can provision or change applications. So just a very broad set of areas that I think people could investigate.
All right, so this is more of a personal question.
Yes.
So you said you were just promoted to SVP in recent years. What advice can you give us as students of steps to take to get in kind of position where you are?
Sure. I think You know, if I step back, and one piece of advice I give people, you really have to do something you like, and that's a very personal thing. But I believe if people are doing something that they find personally rewarding and that they enjoy, they're going to excel at it, and ultimately rewards catch up with that. So I was very fortunate that I enjoyed communications very early on in my engineering career. I was always intrigued by the notion of connecting people, and I pursued that from an academic perspective in fiber optics, and my senior design project was around connecting to what you would consider very primitive processors together, and I just kind of followed that compelling vision of what motivated me personally. And the other aspect of it I mentioned in the beginning is I was fortunate and not maybe smart enough to get into a technology area that was pretty much at its infancy. And if you think about all of these trends, and I know that you're all daily basis dealing with kind of social media and the front ends of this technology, think through all the things that have to go in the background, all this complexity and scale. And I think there's opportunities for people around that are dealing in software in many different areas. So bottom line is follow what you like to do and do it really well.
John, there's a couple of questions up there, number 2 and number 3.
Number 2, how does software licensing change as we move towards more consumer-centric cloud? Do I have to pay for multiple services or no? That's actually an excellent question. So the notion is, and it manifests itself in many different ways. Today you buy a piece of software, you might download it and pay for it once and run it on the internet. This notion of the cloud is going to change what we call consumption models, right? So a lot of the services that you see today are paid for by advertising. So if you think about a Google, right, is this an advertising-driven model, much like early TV went to an advertising model. People are interested in subscription models. So now you pay for software like you would a magazine. So you get a service. That tends to be the way that we have WebEx, our software as a service. You pay by the month, or you can pay by hours or minutes. So generally, I think we're going to see a wide degree and variation of business models. So if we were talking to the business school today, we would be encouraging them to think about how they would change new business models to deal with this new world of cloud computing, because it can't be the same way it was. Excellent question. Another question is, how much of my own data do I use when using the cloud? Do I own? How much of my own data do I own? That's going to vary with your cloud service provider, right? And also their policy around how they use and store your information. And this is an area as well where enterprises would be very concerned about very more restrictive use of their information. If they're going to put customer information or credit cards on the cloud, they're going to be very concerned about its security. When we're using the cloud more in our personal lives, I think we have privacy statements that we adhere to that dictate what those companies do with that information. So it's going to vary widely. Any other live questions?
Talking about this licensing issue, if there is conflict between the cloud provider and the person who is using that cloud, so who owns the data? So how does it gets decided? And like, if my application is on some particular cloud and my data is residing on their cloud, so and if I end up in a conflict with the cloud provider, so how that conflict is resolved? Again,
There'll be many different models depending on the cloud provider. What enterprises would be most interested in is what they call a service level agreement. So today, if a company here in the Valley was going to get phone service from Verizon or AT&T, Verizon would give a service level agreement on how much usage or bandwidth that they would receive, the reliability of that service and its uptime. So what we envision here is that cloud providers to enterprises would also put in service level agreements that would say how much information that could be consumed from the cloud, how much storage they get, the application uptime and the nature of those services. Now enterprises would be interested in monitoring that, so they may have something on their premise, something maybe like a router, that actually looks at the metering of that information and actually can monitor that on their side. So you think of the electric meter on the side of your house, you can check it as an individual. So those things are areas that actually still have to be developed. In our consumer use of the cloud, it's all very casual, right? So those agreements aren't there. There's no obligation to serve you consumer email. It can go off, it can come up, but it has to get much more stringent for general enterprise use.
The current problem with cloud computing is regarding the security. So if we talk about the private cloud and a public cloud, so if an organization is more focused towards its security, should it always switch to a private cloud because it will always be a costly solution for it? Or the public cloud are still working on some measures so that they can still take care of the security even if multiple virtual machines are hosted on a single server?
Right, right. So I think that you know, we're still in the very early days here. There are efforts, both standardization efforts, working on cloud security. There's also, I think you'll see new suppliers of cloud services that cater more to the enterprise and security needs. Also, I would say that enterprises look at what applications they're running. We call it core versus context. What's core to my business, and what might be something that I'm not as concerned about security or uptime, and I move over to the cloud. And they each make those decisions based on the nature of those businesses.
As you mentioned earlier in the slides, it started with mainframe programming or mainframe systems and going to desktop computing, and now it's predicted that things are going to move further into the cloud. Do you think that in the future there'll be like a snapback from the cloud to more personal resources than distributed in public resources?
I don't know what that wave will be, but I would say pretty much yes, because I think I've been around in this industry long enough that the centralization, decentralization becomes a theme that seems to just vibrate through our industry. So right now we're seeing this trend back to cloud, really driven by efficiency. At the same time, I would contend that your devices are getting smarter and more intelligent in what they're rendering in terms of screens. So it may be a different form of intelligence than we've seen in the past as the compute piece gets back to the data center, but other forms, I think, of intelligence will start to come back to endpoints.